Hey everyone, so I'm going to show you how to find the equation of a normal. So if you didn't watch my previous video on how to find the equation of a tangent, I highly recommend that, okay, because this is very similar. Now again, we have an equation, a formula to use, but I'm just going to go over the idea of it, okay, because once you understand the idea, it's comes to you a lot quicker. So we have this tangent, right? And if you haven't heard of what a normal is just at that point where we got the tangent, it's the same point, but we're going to draw a perpendicular line. Okay, and that's what we call the normal. Okay, so if you think about it, the point is still the same point, and the only thing that differs is the gradient, right? Because we're still going to the same point, but the line has a different gradient. Okay, it's perpendicular. So hopefully we can remember, like if I have two lines and they're perpendicular, that one has gradient of m1, that one has gradient of m2, we should know by now m1 times m2 gives us a gradient of -1, right? So if I were to just rearrange this, if you know the gradient of, say, a tangent, the gradient of the normal would be this value here, the negative reciprocal. Okay, and that's kind of what you see written there. Okay, so hopefully that this function notation doesn't look too confusing. Again, all we're really doing is just finding the equation of a line. That's what we're doing. Okay, so let's try to find the equation of some normals. Okay, we're going to start off with just a couple gradient questions. So in this one, what are the coordinates of the point on this curve where the gradient of the normal is 1? Okay, so if we just start differentiating this, we get 2x minus 3. So this is our gradient function. Now remember, this gives us the gradient function of a tangent. Okay, so this is, I'm just going to write here, gradient function of a tangent, right? That means the gradient function of a normal, like gradient function of a normal, would be the negative reciprocal of it, right? Which is kind of what we talked about over here. So it's saying that we want the gradient of the normal to be 1. So we've got the gradient of the normal here, and we want this to be 1. So let's simplify. I'm going to multiply the denominator to the other side, and we can try to solve this. Add 3 to both sides, and we get x equals to 1. Now make sure to read the question carefully. It says, what are the coordinates of the points? So we have the x coordinate, and make sure to just sub it in and find the y coordinate. Okay, so sub into fx. So f1 equals to 1 squared minus 3 times 1 plus 1. That's -1. So therefore, 1 minus 1 is the coordinate. Okay. Now, before I wrap up this video, I'm just going to show you how to find the... Oh, here we go. So actually, I want to try a bit of a harder one. Yeah, actually, I'll just go back to this question. Okay, so it says find the gradient of the tangent to this hyperbola at x equals to 3. Okay, now when you see something like this and we're trying to differentiate, just remember, like, we just know how to differentiate it when we have one of the pronumerals on either side. Okay, so if I make y the subject and I have 1 over x, then from here, then I can say, okay, let's differentiate y in terms of x. Okay, now this one, before you differentiate, probably better to change it to an index form so that we can bring the power down and subtract 1 of the power, which gives us 1 on x squared. So, so we can say sub x equals to 3, And then the gradient equals to 1 over 3 squared. Gradient equals to 1 over 9. Okay, if we have the gradient of the tangent, the next question, finding the gradient of the normal, is super easy, right? So remember how we had, if you have two lines that are perpendicular, then the gradients multiplied to give us -1, right? So we already know one of the gradients. So this is the other gradient. -1 equals to 9. Okay, so that's the answer, and that's the answer. And the last one, before I close out this video, is just finding the equation of the normal. Okay, so once you have the gradient, we need a gradient and a point, right? So we want to sub it into this. Okay, now we already have one x coordinate. We need to know the corresponding y coordinate to this guy. Okay, so maybe we can just sub it into our equation and say 3y equals to 1. Okay, if you sub x equals to 3, then y equals to 1/3. Okay, so for us, the point is 3 and 1/3, and the gradient is equal to 9. Okay, so let's sub it into our equation formula. So y minus y1 equals to gradient x minus x1. Now this question didn't really specify if they want it in gradient intercept form or just general form. In this question, I'm just going to go for general form just so that we can have no fractions. So let's multiply 3 everywhere. 3y minus 1 equals to 27x minus, this is 81. And let's say 27x minus 3y minus 80. And it looks like, no, we can't, that's it. So yeah, so that's how you find the equation of a normal. Okay, so hopefully that was helpful, and I'll catch you guys in the next one. See yous.